Hey, so now that we know all about rotation and revolution, I want you to think about this. What is the reason for the seasons? Why do we have different seasons? So, the reason for this, and I'd like you to write this down, is that the Earth is tilted on its axis. We mentioned before about the fact that the axis is the point, the invisible line on which it spins. But you'll notice that instead of it just being straight up and down, every globe you've ever seen is tilted just a little bit, precisely 23.5 degrees. And because of that, the Earth gets different amounts of direct sunlight. So if the sun is on the right side over here and the sun's rays are coming over this way, we can see that because the Earth is tilted, at least the northern hemisphere in this diagram is tilted away from that. The equator is lifted upwards, and there's actually less amount of sunlight coming up here for the entire northern hemisphere than there is down here. There's way more over there. So because of that, I want you to make a prediction. What season are we experiencing here in the northern hemisphere? Because we're getting so much less direct sunlight, it is going to be the coldest of the seasons, which would be winter. And that means on the other side of the Earth, the southern hemisphere, it's the complete opposite. So they're going to have summer during this time. Now, this location over here would be like when the Earth is over there. So that would be winter, and that means on the total other side, it's tilted towards the sun, which means that that would be summer. And then if this is winter and this is summer and it's coming down over here, that would of course mean that in this particular diagram, that this would be the transition time between those two different things, which would be spring. And over there would be fall because that's getting an equal amount. So even though we're heading in different directions in terms of getting colder or getting warmer, it's going to be roughly similar types of temperatures that we're going to get in the northern and southern hemisphere during these two times over here, depending on the types of latitudes that we're at. So axial tilt is the reason for the seasons. We see over here one more time that tilted away, right? It's winter, tilted towards, you get summer. And then, it takes about 6 months to get to the other side over here. And then that's when we get our summer. And Southern Hemisphere gets their winter. So let's take a look at some dates. Now, as we go through these dates, I do have to say that sometimes these dates are incorrect. They're always in the right months, but sometimes the dates themselves can change depending on the year. So you'll have to look up to see what year we're currently in and what it currently is. But if we were to fill this out right over here, we have certain words that are correct, but not entirely there. So we're going to start over here with the winter solstice. Again, the Earth is tilted away. This is happening during December. And this is going to be the day of the year where essentially it is the shortest day. What they mean by that is, of course, every day is still 24 hours, but the daylight is going to be the least amount of time that the sun is out throughout the time. And I'm sure you've experienced that. You know what that's like in the winter time when all of a sudden you go outside, maybe you stay a little bit after school, and by the time you leave school, it's completely dark out, right? So we get the most amount of darkness during that time. So the winter solstice is that date where the sun is at the lowest point in the sky. Now, as we move forward in time over here, the Earth moves from here to there. We're now at the vernal equinox, sometimes known as the spring equinox. So, vernal, think of like verde, which means green. It's springtime, everything's blooming. And this is the time where equinox is like equal night. And it's an equal point in the sky. We're getting similar amounts of daylight and darkness in the night sky, or in the day sky, too. As we jump forward, June 22nd is the summer solstice. This is going to be the longest day of the year, again, which just means the most amount of daylight. So this happens right around here in June, and this is also the first day of summer, would be the summer solstice as we're transitioning into a period of hottest time of year, and also the end of the school year, which is not so bad. And then finally, we go over here. This is the autumnal equinox, the fall equinox, and just like the vernal equinox over here, it's equal amounts of daylight and darkness over there. And then that becomes the full year. So, one fun thing to consider, which I like to do, is what if the Earth was tilted even more on its axis? How would that impact the following things in both summer and winter time? So, if we were to take our 23.5 degrees and increase it an additional 26 degrees, now look at the where the equator would be how different the equator would be as it goes back and forth over there, and just the difference over here. So now, as the Earth is spinning around and as it's revolving around, during those times of summer, well, how would the height be of the sun in the sky? It would be really high up. So if we were having very long times, if the sun was setting at 8 or 9 p.m., it could be midnight. It could be 24 hours of daylight during that time, potentially. And then maybe on the other side, absolutely no daylight in the winter, which would be pretty crazy. The length of the day, right? The length of the day is entirely corresponding to how high of the sun is in the sky. So the length of the day, of course, what we mean is that it would be incredibly long. What would the temperatures be like? Well, if we're getting so much direct sunlight during that time, we would have incredibly hot summers and incredibly cold winters. This would be a really drastic thing for all of life to adapt to. And it is possible that if it was like this originally, maybe life wouldn't have developed the way that it is here on planet Earth because it would just be such extremes. We're in an area where we do have all the different seasons, and we have certain animals have adjusted to that. But if it was like a tropical rainforest type situation in the summer and a tundra, frozen tundra in the winter, we have specialist animals that have been adapted to that. I think it would be really difficult for life on Earth to adapt to that, but maybe life would find a way.